the azaleas are blooming. They're about gone, I believe. But we have a beautiful spring, a lot of beautiful trees blooming and so forth. We have as our guest tonight, Carlos Hunter, who is involved in establishing renewable energy, solar energy project up in Michigan on a site that's kind of interesting. It was a mining site for iron ore, and this is the site where where they stack the waste tailings, and it's kind of I guess, a hazardous waste site, so to speak. Nothing hardly grows on it, and but it's being put to good use to produce renewable energy. Welcome, Carlos.
That's right.
Tell us
Thank you,
about
Harold.
your project. What is it? How many megawatts of power it produces?
Yeah, so like Harold mentioned, I work for a company that is developing projects primarily in Michigan and in the MISO market in the Midwest, but a big focus in Michigan. Ever since we started the company back in it was 2017. What we really started doing was trying to find sites that were underutilized, where you could gain more community acceptance, where we weren't trying to railroad communities in terms of pushing projects down their throats.
And the big issue is taking up farmland.
And a big issue is taking up farmland, which I don't have a problem with, but generally speaking, if you
the farmers don't like it.
Well, the landowners like it. The farmers definitely do not. Well, a lot of farmers don't. A lot of farmers do. But generally speaking, if you can find a site which can be repurposed and give back to its community, both in the property taxes it pays and the commitments that it makes to its community, both in terms of decommissioning the project, as well as guaranteeing that it's paying property taxes into the community, as well as providing energy that's competitive, based on the other available technologies, or the fuel mix with the utility that they buy power from, then I see no reason, even getting away from the political aspects of renewable energy on whether or not, how green renewable energy is versus the different alternatives.
And a big issue is it's a low cost.
Yeah, I think the costs and the economics start
very low
speaking for
environmental
themselves.
impact and low cost.
That's right.
And you can offer long-term, fixed price, low cost power.
Yeah, that's really what's
It's
been.
not like gas that changes in price or coal that changes in price constantly.
That's right. So when you build a renewable energy project, and by renewables right now I'm primarily talking about solar, although I have worked on wind projects in the past, but particularly with solar, when you're building a solar project, most of your capital expenditures are all up front. I mean, you're buying equipment that's primarily the panels themselves, steel racking, inverters, and then your equipment to tie into the
Now the price of the panels have both become more efficient and less in cost.
That's right. The efficiency has gone up slower than the price has come down, I would say.
Yeah.
The cost has been incredible. The declines in solar costs ever since I've started working in renewables, which was about 15 years ago, I've seen the prices come down, approximately 80%, which is
Wow.
incredible. Originally, when I started working in solar,
Which makes solar very cheap.
yeah, I mean, originally, you would be able to install solar, and by, what I'm talking about is utility scale solar, where you can gain some economies of scale of building something, in a contiguous project that's interconnecting to sell power on the wholesale market, that sells power to utilities directly, and some commercial customers potentially as well, but not to directly to homes. But I've seen pricing start when I started getting into the business. It was the installed cost of a solar project in the U.S. was over around $2.50 per watt installed, and today you see projects, depending on where they are, there's more efficient projects than others, but you've seen prices come down closer to $1 a watt. So, and specifically the biggest input cost
So
there.
that's about $1 million a megawatt.
Exactly.
Yeah.
And, you know,
Which is really cheap, wind it certainly costs more
absolutely.
than that.
So
And a coal plant costs a lot more than that.
yes,
And it burns coal.
exactly. I guess the difference being obviously solar only produces when the sun is shining. However, I would argue when the sun is shining,
Is
it
when you
sells.
need it the most.
It's luckily it is when we need it the most. It's usually when our air
Yeah.
conditioning units are running.
And we look at, you talk about how much solar produces, like about 6 hours a day for the year, so that's about 2,200 hours of output.
So it produces energy at, if you looked at it at full capacity and averaged it around 20 to 25% of efficiency.
Yeah.
Now,
Which
where,
is real close to wind.
well, depends on where you are. Wind, I've seen projects in the 30s to 50%, depending on where you are. West Texas wind projects produce a lot, but the thing there is, as you mentioned, solar today produces power when you usually need it most.
And there's a lot less maintenance on a solar power unit than on a wind turbine unit.
That's also true.
Lightning hit the blades and it really messes things up.
Although, I mean, even then, wind can be very complementary to solar, and in certain places, it works fantastic. And I would argue West Texas projects.
Yeah, when your high pressure systems come in, high heat and no wind, and that's when solar is at its peak.
Well,
So
yeah,
they
exactly.
complement each other.
That's true.
Yeah.
And even more so. So during the time that solar produces, it sells energy cheaper than anything else.
Yeah.
And so it sells today the levelized cost of energy. So if you looked at how much a project of different technologies needs to sell energy at to make a return, to be profitable, solar can do that cheaper than anything else on an unsubsidized basis. So taking the subsidies and the Inflation Reduction Act out of it, and if you took tariffs out of it as well, because of what you're saying globally, from that perspective, it is the cheapest. Now, with that said,
It's not like running a power plant. There's not many people, doesn't take many people to run a solar facility.
no, but with that
Somebody
said,
to cut the grass, I guess.
you can't run the whole grid off of just solar, obviously. So today in MISO, which is where Louisiana is interconnected to, I think around 6% of power is coming from solar today, which is pretty great. And I think also between 6 and 7% is coming from wind. Right now it's most capacity additions onto our grid are going to be solar. Eventually, you start running into issues where the pricing there's too much solar on the grid during the day. You'll start seeing the pricing differentials happen. You'll see what's called a duck curve, where actually the pricing in the middle of the day starts becoming so cheap because there's more and more solar online.
Yeah.
And you have to start backing it up with natural gas is a fantastic way to back it up, and it's very complementary to solar. And the same with wind, and now ultimately batteries are starting to become a lot cheaper.
So, and Louisiana is very active in this solar, generation.
It is.
And, I think we have 5 or 6 facilities within 50 miles of Lafayette.
Yeah, and so
That's some real big ones.
it's so. I mean, the amount of projects being developed in the country is pretty staggering, actually. So, in Louisiana today, there are 29 gigawatts of power projects in the queue, so in line to connect or to be developed, and all I guess
A gigawatt is 1,000 megawatts,
around
right?
22 gigawatts of that are solar. So that's almost all of the energy that Louisiana needs in just projects that are trying to be built with solar. Now, obviously, most of those, or I wouldn't say most, but a lot of those won't be built, and some of them will be built sooner than others. But generally speaking, most of the utilities these days. So how utilities typically figure out what their plans are over the next 5 to 10 years is they put something together called an integrated resource plan. And so those integrated resource plans, and it works like this in most states, are presented to the state's Public Service Commission, who's responsible for making sure that utility hired both an independent consultant that is capable of evaluating various technological options in both what's going to be built as well as how it's contracted and bid out to be built. So utilities typically like to own a lot of their own infrastructure, but at the end of the day, there's also a lot of private companies that can be equal or if not more competitive than those utilities themselves. And so, letting the free markets compete to come up with the most efficient and cost competitive technology is usually the best way to go about it. And so the Public Service Commission has a tricky job in terms of how much it pushes back on utilities and how much it allows independent developers to participate in selling power into the grid. But with that said, most integrated resource plans you've seen over the past couple of years, and Entergy in Louisiana is a great example. Right now, most utilities are shutting down coal, and the reason being
including Lafayette.
And the reason being is twofold. One, environmentally, there are a lot of environmental regulations that are putting challenges on the coal industry and on coal power plants. But even with that said, the reason why these projects aren't operating as much as they used to, even before the environmental regulation kicks in from the good neighbor rules that are coming out from the EPA, are purely economical reasons, because solar is selling power onto the grid at peak times. Between you see a lot of these purchase power agreements being bought by solar projects between 3 and 4 cents a kilowatt hour, and that price is cheaper than a coal plant can actually produce. The marginal cost of that coal plant to burn coal to produce electricity.
Right.
And so, unfortunately, our MISO right now, the market isn't set up to. The market was developed, many years ago to where you generally had a lot of centralized large power plants owned by utilities throughout the grid, and so most of the generation mix was these large gas and coal plants throughout the grid.
Yeah.
And now that you're having a lot more distributed resources, including solar, smaller gas projects being built throughout, that generation mix is changing, but also
and there's an economics issue involved. You lose power sending it a long ways, so you have transmission fees.
Exactly.
Transformers, all these things are.
The grid was originally developed for the central power plants to send their power out and get it to the home. Now
send it out 100 miles.
Exactly. Now you're having a lot of projects that are more distributed, which actually does add a lot of reliability benefits to a grid.
For sure.
But with that said, the grid, but particularly
you can imagine, a hurricane's not going to bother solar facilities.
Well, depending on how strong and where, but generally speaking, if you have solar facilities that are spread out all over the state, the odds of that hurricane taking down all of them is very versus that hurricane hitting one large gas or coal plant that's centralized that produces a big percentage. Having distributed resources gives you more
knocking
reliability.
down big power lines. That's another big issue.
Yep, but the market itself, the wholesale market in MISO, unfortunately doesn't compensate reliability as much as it should, and the reason being the market wasn't developed necessarily with the foresight of solar, the prices of solar coming down so quickly, and the majority of projects being built being solar. So MISO is in the process.
The price of wind is coming down also.
Same equally. Wind in a lot of places, not as much in the south. Because the wind resource isn't as good here as it is in northern MISO or in the New England or West Texas.
Our land resource is not very good in Louisiana. It's great in Texas.
Exactly, and especially West Texas.
West Texas, yeah.
And so MISO right now is in the process because they're forecasting this is going to be a reliability challenge in the future. If you have all the solar built out and you have a lot of the coal plants shutting down, even if you keep your gas as it is, and then on top of that, we're adding a lot of load to the grid from electric vehicles, from a lot of data centers, so the AI data centers.
It's astounding how much power it takes to run an electric car.
It is, and so
120 kW, and the average home is using 1.2 kW an hour. So
we're adding a lot of load.
That load, that charging that unit will give power for 106 homes. And you start saying, well, let's say we're going to have 10% electric cars on the Lafayette market in 3 years, which could very well be.
Yeah, I don't know the numbers. Like I think it's a little bit less than that, but it all depends on when people are charging, and the loads are very significant when
they're either driving or they're charging.
Yeah, I mean, generally
So you'll be
speaking.
charging,
Um,
yeah, you're either
but
driving or you're charging.
and with that said, also, not as, I don't know in Louisiana specifically how many data centers and cloud computing or, data centers are being built, especially with,
And
a lot of
they
them
have
targeting AI. But electrical load is definitely expected to increase over time. And so what,
And we really not, as we take our coal plants, we're not really replacing that generating capacity.
we are, but mostly with solar.
Solar.
And so right now, especially in the projects that are in line to be built to replace that capacity, it's mostly solar. So both the states within MISO as well as MISO itself are seeing this, and so they've been projecting that we're going to run into challenges in the future. But again, they've been projecting this, and we're a long ways away until it actually is a problem. But utilities move slow, regulatory agencies move slow, so you have to start tackling these challenges today. And so MISO is now going through and starting to change the way that companies get accredited and compensated to sell capacity resources, which are really what capacity resources you can kind of you would attribute those more to reliability versus energy is not as much reliability because it trades on 15-minute
Sure.
intervals.
Yeah.
And with that said, the one positive throughout all of this is we have a lot of natural gas in this country. One and two.
And that technology keeps getting better and better.
It does, and then two, battery prices for
And
utility.
then hydrogen will come in, because I guess the latest combined cycle units can burn gas or hydrogen or a mix.
Or a mix, exactly.
And at 63% efficiency,
So
which
and
is
that'll
phenomenal. That's 3 cents per hour.
definitely lower emissions for gas, generally speaking. But even transitioning away from coal to natural gas has lowered emissions more than anything in this country. And now the next wave is going to be the implementation of renewables, which aren't necessarily replacing as much of that natural gas fleet, but they are bringing power that's going to be needed for the expected load from EVs and data centers and electrification, generally speaking.
Yeah.
And then on top of that, the good thing is on the utility scale side for batteries, battery prices have also been coming down even faster than solar prices that ultimately came down. So
And that technology is getting better and better.
It's getting better and
That's
better.
part of what's bringing the prices down.
and batteries, batteries for utility scale applications, meaning batteries that you're charging on the grid, so you're charging with solar. Today, most of those batteries are very similar than what you see in an electric car. They're lithium-ion batteries, but there's a lot of different technologies that are now being implemented with sodium-ion batteries or other forms of other chemistry compositions of batteries that aren't as focused as much on the density of those batteries because you're not trying to cram them into a car. And with that comes less of a need potentially for rare earth minerals, as well as at the end of the day, also you're targeting something else in terms of how you're operating these batteries, generally speaking. But
Your facility in Michigan is 130 megawatts. That's probably a third of the power that Lafayette needs.
it's 120. I think Lafayette's load is around 500 megawatts.
It peaked at 506,
Peaked at 506.
This past summer.
Okay.
Which is the top. That's of course, super hot summer. But how much battery capacity? What percentage of your output can you put into batteries?
So I mean, you can put as much as you can put all of it if you'd like, but that's not efficient to do, obviously. So I guess
at what cost is it?
Exactly.
Yeah.
So right now,
If you're charging batteries, you're not selling that power.
No, not well. You could at a different time.
At a different time.
So, for instance, if reasonably speaking, there's a couple of things that the people that are building a lot of battery projects, which I'm starting to develop some battery projects in Michigan as well. But for instance, most batteries over the past couple of years have been built in Texas and California. And Texas's market is set up a little bit differently than Louisiana's.
They have their own market.
They have their own market. They don't have a capacity market, but they have a very, very robust ancillary services market, and it's made it very efficient for those batteries to trade and sell
They're
different.
about 25% renewable.
I think at certain points they are, yeah.
Yeah, right.
And so at that point, they have needed a lot of batteries to come in. But what you know, when you're sizing a battery for
The
the grid,
battery works for wind and solar.
it does.
Yeah.
In Texas, most batteries that have been deployed have been 2-hour duration batteries. That has been recently kind of the sweet spot of making it economic to sell different, you know, you know, to kind of, but in MISO, we're in Louisiana, how a battery gets accredited to sell capacity, which is where it makes most of its money, it has to be a 4-hour battery for it to be accredited as a full
Wow.
capacity resource. So as a starting point, you have to build a 4 MWh battery, and it is starting to become economic just from capacity revenue, and then also eventually selling energy when it's
And
buying,
what's the
charging them when it's cheap.
durability of those batteries? You can expect 5 years, 10 years?
Oh,
life?
no, yeah, I mean, you know, by year 10, if you looked at what you call a degradation curve, and these battery suppliers will actually give you a warranty. You can have a 5 or 10 year warranty on a specific degradation curve where they guarantee that you're operating that battery where you're cycling it every day. So you're charging and discharging that battery
Every day.
once a day. By the 10th year, you still have around 80% of the capacity of that battery
Wow.
available.
That's phenomenal.
Which is phenomenal. So again, it's only using it once a day, and you have to be very careful about the. So now there's a lot of groups that are using AI or different operating algorithms to optimize battery degradation, as well as how and when you're selling and charging for power. And optimizing that mix is critically important, and also temperature control matters tremendously in that, because if you keep your
So
batteries
first,
cool.
so the most need is the first 4 hours after sunset.
Yeah,
Yeah.
in most cases, that's right.
Yeah.
In most cases, that's
If
right.
your need for power goes drastically down from midnight to
But
late in the morning.
right now, you know, for instance, in MISO, you know, you would make most of the money, you know, as a standby resource for those 4 hours. So even without operating the battery, which is what a lot of gas peakers do, so they might operate even 60 to 100 hours a year. And they make most of their money actually just for being on the grid as a standby, reliable resource for when the time comes, they can and operate it. And you usually do see that, you know, when we have these winter storms and gas prices spike. What sets the marginal cost of power during those hours, usually have a merit order dispatch. So the cheapest energy gets dispatched first, and then all the way to the most expensive energy. You know, that's what you'll see. So you'll see those gas peakers come online at those times. And you know, right now, just based on what everyone is foreseeing in terms of the reliability challenges that MISO is going to face, people are starting to believe that the market for capacity is going to top out in the next couple of years, and it's going to make it attractive again for gas projects to start being developed again, but also for a lot more batteries to be deployed. Now the challenge is going to be obviously are those 4 hours enough, and what is FERC, what is MISO, what is the state going to do to incentivize, you know, situations where you need more than 4 hours?
Yeah.
And so there's going to be it's going to be a lot of evolution in terms of how these markets change over time to accommodate.
Carlos, are you familiar with Lafayette's plan going forward? Have you looked at that?
Not as much as I'd like. I saw that. So you know, I moved to
Well,
Lafayette.
they totally relied on MISO.
Yeah. Well,
Buy all their power from MISO.
last time I saw, Lafayette did an integrated resource plan, and I think they hired Burns and McDonald, which is a great consultant engineering company that I think evaluated the different options for LUS. I don't know when that was done. I think 2020 or 2021. I haven't been too familiar keeping track too much of
Yeah, they're
LUS's
building
plans,
they're replacing their 250 megawatts of power from the coal plant, which they can't get 250 megawatts here.
yeah.
You can't send it 100 miles and keep all of it.
So I guess so they're getting the majority of their power from MISO, as well as have a couple gas.
They're getting all that stuff from MISO.
They have some combined cycle gas plants, or they
No.
Or I guess
We
their plan
have
is
a
to
single cycle
a single cycle.
with two
Two
single
peakers.
cycles gas peakers,
Okay.
which only run 2 or 3% of the time.
Yeah.
And the new, it's a large Siemens 5000,
Yep.
single cycle, about 30% efficient. It only run 870 hours a year.
Yeah, how
It's
many,
only
870?
807, that's
Yeah.
10% of the time.
But I would argue,
The solar will put out
Of
almost
course.
3 times more.
the difference there is I would argue that plant is gonna make up the majority of its money as a standby resource, aside
That's
from
right.
operating for those times. And so, yeah, if that's correct, then LUS is primarily buying their energy on the wholesale market through MISO.
Right, all of it.
And
Yeah.
and so far, I would argue, I don't know how these plans were made. It's probably actually been worked out really well over the past couple of years because
Yeah.
natural gas prices are almost at an all-time low right now.
Yeah, $1.80.
But again, the problem there is that those things change and they evolve very quickly.
Yeah,
So,
and my argument would be that there are people who run merchant power plants would probably come in and build a facility for a 15-year contract at X price.
yeah, so if LUS did, and I'm sure, and I
And
think
that's local power, so you don't have transmission charges,
that's true. That's right.
you have a lot of reliability, you don't have lines covering hundreds of miles, you're not paying MISO studies and MISO transmission upgrades.
So yeah, LUS could buy power, either develop it themselves or if they bid it out to independent power producers.
Independent power, merchant power people.
Usually, how renewable energy projects get contracted, how a project is built is, someone will develop a project. So you'll do your engineering, you'll do your permitting, you'll go through the MISO interconnection process, but then to actually get something built, and to be as competitive as possible, you have to sell the energy.
Yeah.
And generally speaking, the industry so far, and different markets have started evolving differently. So in Texas, this isn't necessarily the case, but in MISO, all projects usually need to start with a long-term purchase power agreement where a utility or commercial off-taker is buying your energy for a 10 to 15 to 20-year period at a predetermined rate.
Yeah.
And it can be a flat rate, or it can be at a rate that escalates with inflation, or you can structure them in a lot of different ways. But generally speaking, again, that price in Louisiana has been around the 4 cent per kilowatt hour range in terms of what I'm sure LUS could probably pick up a PPA at. And whether or not that might be slightly higher than what the wholesale market's been
We're
this
paying
year.
4.5 cents for transmission fees.
There you go. So generally
You had
speaking,
8.5 cents, and
I would be shocked if that wasn't the most competitive energy that LUS could buy. Now, again,
if we produce
that would be a
it
good
here
start.
with combined cycle units and we
some
tapped
solar.
into the local solar, we could lower the hell out of the
I'm
price.
sure, and you would be hedging yourself for the future in case,
Yeah,
again,
yeah.
once the electrification.
You all
race
signed
starts happening.
10 or 15-year contracts? for
I
sale?
do, yeah.
Yeah.
Yeah, for most of the
So,
projects that I've done.
and that's
yeah.
a fixed price?
It is.
That really stabilizes your cost factor.
Yeah, I mean, hedging part of your fuel mix as a utility is always something
And
that I think is
the
very
cost of the
beneficial.
sun is always the same.
It is.
Yeah.
Now, I mean, again, at the end of the day, right now it's worked out, but who's to say? I mean, we're going to have a lot of load, and a lot of increases in load through EVs, through electrification of all sorts of things in our
West
economy.
Texas and New Mexico facing a big load with just pumping oil.
Yeah.
I mean, all these Permian Basin projects, they don't have any pressure to push the oil out. You got to pump it out, and that's virtually all electric.
Yeah, no, I mean, and on top of that, I mean, in Texas, the load increases in Texas have been incredible. Also from, again, a lot of it from the
Population growth.
economic growth in
Yeah.
Texas has been tremendous, but also,
So we're not having that problem in Louisiana.
no, but you've had also, for instance, you would be surprised about how much these data centers and also even like crypto mining operations, how much energy they use, and a lot of them have been done in Texas because in Texas, the market, especially for ancillary services, you get paid to be an intermittent load resource. So a lot of these crypto miners, because they can shut off and get paid for it in certain times, they will do that. And then secondly, you have so many renewable resources in Texas, especially coming from
You
West
have
Texas.
these energy brokers in
that
Texas.
it's been tremendously efficient for them.
It's
to
a
do it.
free market all across the state.
right.
You can hire an energy broker. And I got to know one of them. He's a guy from Russia. His dad was a Baptist minister. So anyway, he invited a scout troop to he has a little ranch that's about 200 acres near Tyler, Texas. So we went and stayed with him a weekend, and I asked him what kind of deal you made with it for your electricity. And he has a camp, and he has a big garage and storage shed and so forth. And he said, well, he says, I'm paying 4 cents a kW. Says, no nighttime charges. No charges from sunset to sunrise. And no weekend charges. From sunset on Friday to sunrise on Monday.
There you go.
I said, how much you paying a month? He says, it's about $40, but I think I can get it cheaper.
Get it cheaper, yeah.
In Louisiana, that would have been $400
Yeah, of course.
easily.
I mean, if he's because he's willing to manage the time of day when he's using his load. And I would, a lot of utilities throughout the country are starting to realize the reliability and capacity shortages that we're going to face, and so they are starting to try to incentivize even retail and residential customers to be able to be more of a flexible load resources where they can ask you to turn off your air conditioning at certain times.
I have a friend that has a home in Peonia, Colorado, and it's kind of in western Colorado. And he's got 160 acres, and he's got a beautiful adobe lodge, and it must be about 1,200 square feet. And he designed this himself. He put up solar panels, and the solar panels charge 10, 12 volt, trolling motor batteries.
Exactly. That's great.
And he's got both 12 volts and 120 in his house, and then he's got butane gas, so that runs the hot water heater, and it's on-demand hot water, and so he has no utility bill. And his first battery went out at about 4.5 years, and he replaced them all, and they're about $100 a piece.
Yeah, because he's using
that's super cheap power,
So I think
so. The technology, we coming closer and closer to the point where individual homeowners can self-power.
Yeah, absolutely.
Yeah.
And I'm pretty sure all the U.S. actually has net metering as an option for homeowners, which a lot of other utilities don't. So I think that's a great benefit. But I think what I would say, generally speaking, renewable energy, regardless of which side of the aisle politically you're on, has become, everything gets politicized these days, and renewable energy is no exception. But I would say, look, at the end of the day, the market and the technology has grown, and the economies of scale of the manufacturing facilities that have been built have lowered the prices so much that at this point it is, at the time when it's producing, it is the most efficient and cheapest resource we have at the moment. Now, to get into maybe some of the policies and the things that have changed over the past couple of years. So, when Obama was president, he started putting tariffs on Chinese imports of solar panels.
Yes.
And China, generally speaking, they've placed a huge importance on building out manufacturing of solar panels, and they did it on a massive scale, and they dropped the price globally. Like for a lot of goods, they're very good at manufacturing, so I'll give you have to give them credit for that. But they were dumping. They were also they got the Treasury. The Trade Department, accused them of dumping panels because a lot of these were state-owned companies. And so at the end of the day, Obama started putting tariffs. Trump kept those tariffs as well as put additional tariffs in place. And the goal has been to kind of reinvigorate domestic manufacturing of solar power and solar technology.
That hasn't worked very well.
And so, it hadn't with the tariffs alone. I will agree. And so the unfortunate situation in the U.S. that we've been hit with is that we pay more for solar panels here than we do in Europe or in Mexico or anywhere else, because we're not buying Chinese panels. Most of the panels that have been coming into the U.S. for the past couple of years have all been coming from Southeast Asia, so Vietnam, Thailand.
Wow.
A lot of them from Chinese-owned companies, but and domestically, we've had a couple. We do have First Solar is a large U.S. domestic manufacturer of solar panels. They're building a big plant in Iberia Parish.
Yes.
That's going to be tremendous. But the Inflation Reduction Act, when it was passed, again, regardless.
We're in a renewable energy incentive zone.
Well, no. So Lafayette itself is not. So the Inflation Reduction Act passed, and again, regardless of how you feel of the politics of it, It is, in part, it does counteract some of the
But
some
it
of the
is going to
tariffs,
Iberia Parish.
some of the tariffs, and and incentivizes buying domestic U.S. made equipment,
Yeah.
which I think is great. And it also incentivizes projects being built in what is called an energy community. And energy communities are based on areas that used to have, where the economy was very dependent on oil and gas or mining, and that have certain levels of unemployment. So it's impoverished areas that used to rely heavily on oil, gas, or mining.
Or you can
And
go
so-
to Morgan City.
Most of Louisiana actually is categorized as an energy
Yeah.
community. So what's great, for what it's worth, what is great is that in Louisiana specifically, Louisiana is at an advantage compared to a lot of other places in the fact that Louisiana has historically, the economy has been very oil and gas dependent, and for what it's worth, the Inflation Reduction Act is incentivizing projects being built in those areas. One, so we are at an advantage for other places, and then two, domestic manufacturing, generally speaking, that is happening all over the place. That's happening in Texas. It was great to see that plant's going to be built, locally here.
And we built another interesting renewable energy plant, I think in Generat, that will take bagasse
Oh, really?
and turn it into fuel pellets.
Oh, that's very interesting.
And the fuel pellets end up in England and Holland and all that. But they take the fuel pellets and they pulverize it into superfine dust and air mix it and put it through combined cycle turbines.
Wow, that's
That's
incredible.
kind of a renewable energy through combined
Yeah.
cycle turbines.
Yeah,
Of
it's
course, we
fun.
could do the same thing here.
Yeah. Oh no, I mean, and we were talking about hydrogen earlier. Hydrogen can be blended into natural gas as well, and the efficiencies are.
That's part of the future because, hydrogen has, the only emission is water vapor.
Yeah, exactly.
It's
And
super,
so,
super clean.
also,
burning, and it,
as
water is full of it.
and what's
Big issue is getting it out.
how the incentives are being lined up as well. Right now,
They set up these hydrogen, what are the hydrogen points where they plan to produce hydrogen? There's
Yeah,
6
so
or 8 of them around the country.
there's the hubs, and
The
again,
hydrogen hub, yeah.
the Inflation Reduction Act has been trying to incentivize certain markets for hydrogen, but
Currently,
Louisiana,
we get hydrogen from natural gas.
yeah, Louisiana is great because we have a lot of the geological features that are that can be used for hydrogen very well. So if you're doing hydrogen, you could do it. You can use an electrolyzer and make hydrogen just out of water, but that takes a lot of electricity.
It takes more electricity than you get.
Exactly.
Yeah.
And so, there are incentives for that, and people are trying to do that, and that's what you call green hydrogen.
Yeah.
Blue hydrogen is making hydrogen out of natural gas.
Yes,
And the ratio, I think, is like 9-1, but
most of it is blue hydrogen.
but a lot of that, you're then the CO2, because we're in Louisiana, we have a lot of old oil reservoirs, we have a lot of saline aquifers, and we have a lot of caverns. And
Giant
there's-
saline aquifers.
and you can pump you can get hydrogen out of the natural gas and pump the CO2 and sequester it, and you can't do that in a lot of places. So I think there's definitely
We
a big
got a
future in
big
hydrogen in
project at
Louisiana.
Intercoastal City, it's an Exxon project. It's a carbon sequestration project, and it's gonna employ a bunch of people. They
That's
gotta
great.
monitor, they gotta do seismograph monitoring of the project for 3 years as they putting it in and they're monitoring what's happening.
I'm sure what's coming out, and you'll see smaller projects built as well. I'm sure. I mean, eventually, the hydrogen economy right now, is growing. I mean, right now you can
Yeah.
use hydrogen for refining purposes. Eventually, you'll start using hydrogen. There's a lot of steel companies that are looking at using hydrogen instead of natural. A lot of things that you would historically use natural gas for, you can use
You can
hydrogen
run
for.
hydrogen in your car.
You can make ammonia out of
Yeah,
hydrogen, for fertilizer.
Yes.
You can, yeah. I mean, there's a lot of there's hydrogen engines and trucks being built. You can do a lot. You can do a lot with hydrogen. So eventually, it'll be interesting to see how
Where it
that
goes, yes.
economy where
The
it goes.
key is to get it economically where, you get more than it costs, so to
Exactly.
speak.
And I would argue right now the only way to do that is with natural gas. But
Yes.
eventually, again, in certain places, if you're in the desert somewhere and you have a ton of solar or excess solar and wind, and you might as well use it for something. And
Yeah,
hydrogen
yeah.
might be a good way of using it.
One of the things, Louisiana has all these coastal bays and those coastal marshes, all of that is probably a great place to put wind resources. But as you pointed out in a conversation with you yesterday, or a couple of days ago, that we don't have very good wind data.
No.
Wind data that a bank will finance a project on. Now, you can get general information about wind, but that's not
Enough.
that's not what you can take to the
That's
bank.
right. Yeah.
So if we monitor it, if we set up, I think there's a device that puts a beam up in the air and monitors.
LiDAR. That's right.
LiDAR beam. And,
Yeah, so-
and so if we set up a grant to monitor that across the coastal area of Louisiana, that might be an opportunity to sell a project.
I think it would unlock a lot of interest for
Yes.
larger developers and larger companies to start
Yeah.
looking. So
Because if you have that information, you can take that to the bank.
for sure. So most of the wind that's been built in this country, and again, the most recent wind that you've seen, again, a lot of it in Texas. But Texas as an example has phenomenal wind resource in West Texas, and a lot of other parts of Texas. But West Texas is very reliable. You're talking,
Amarillo,
8, 9 meters a second, which means that these machines are topping out at, again, like 40 to 50% net capacity factors, which is incredible.
Yeah.
So that's some of the cheapest power. And once you get to Louisiana, we don't have that similar resource. In the Gulf, you also don't see the same resource as you've seen, for instance, in New England, where, yes, they've been trying to do some offshore wind projects out there. New England has a lot of challenges that we don't, though. For instance, we have a lot of natural gas here.
They have deep water out there that makes it really expensive. They had 5 or 6 million a megawatt to install.
But they also have their
high price electricity.
Well, their wind speeds are almost twice as much as they are here. They have 9 to 10 meters a second average wind speeds off the coast of New England. They're very very reliable. But on top, that still isn't enough. On top of that, though, New England doesn't have nearly the natural gas capacity that we do, so they have very expensive power, and they're more land constrained.
Marcellus?
Well, Pennsylvania does, but I mean, I don't know.
They don't even let them drill for it in New York.
Yeah,
So.
well, New York is its own market. It's just like ERCOT in Texas is its own market, New York its own market, and then you also have the ISO New England as its own market. So Massachusetts, Maine, Rhode Island is its own market, and very expensive power prices. But generally speaking, again, there are projects that are being built out there offshore. There was a big push, politically. You saw the previous governor announce it, and also, part of the Bureau of Ocean Management was going to auction off these large blocks of area in the Gulf.
Off of Lake Charles, yeah.
To try to put some offshore wind turbines out there. The issue that we ran into is that you're in MISO South. We have a lot of very cheap power down here. We have a lot of natural gas, and the wind resource isn't as good to take that risk. And so no one. It's my understanding that no one actually came out and bid, and nothing was awarded, and that's a real shame. But to your point, Harold, the biggest cost of building an offshore wind rig is
Putting the units out there.
Is putting them out there and having these massive, essentially floating oil platforms with wind turbines on them.
Yeah.
And if you could do that in closer to intercoastal bays,
Yeah, you've eaten the coastal bays, like White Lake is 8 to 10 feet deep. It's around 70,000 acres, and it's always fresh water.
exactly.
And it's totally enclosed. There's no big ocean waves come through it. So,
And I think the wind resource there is, again, the
and I have a wind study done by Fugro, and it compared to the data we got off of Galveston,
Okay.
10 miles out. And the results of the study showed that there'd be about an 8 or 9% reduction in overall wind output. But, if you went from 10 miles offshore and went to Galveston Bay, you'd probably have close to the same reduction. But
yeah.
to go into the bay, you're reducing the cost.
Oh yeah.
The project off of Galveston was in 50 feet of water. Now, to build a platform, you put in 50 feet of water, you got 120 tons of material. And you could put a platform in 8 feet of water,
Yeah.
and you're going to have 20 tons of material. You
Yeah,
got,
plus
a
you
small lift boat can handle it, you know,
And you're
it's no
using,
cost per ton.
you're using turbines, you're using onshore wind
You
turbine
could use
technology.
offshore wind turbines, you could use onshore turbines in those shallow bays.
Exactly.
You wouldn't need the marine turbines.
I think so. So back to your point on the wind resource. So right now, most a wind developer when they're prospecting for sites, you have to find a couple different characteristics. One, you have to be close to transmission line.
Yeah.
That you can sell the power into. Two, the wind resource that you're doing, most of it's again at this point. When you're screening, you're looking at desktop resources, and the best desktop resource we have right now is a company called AWS True Power, and they were, I think, originally they were in part funded by the National Renewable Energy Laboratory, that's part of the Federal Regulatory Energy Commission, and they put together this unbelievable mesoscale data set. Which I think was mostly using satellites as well as a lot of, and then correlated with a lot of the land measurements, and so that gives you a pretty good picture, plus or minus 10%. I think it's less than that, but generally speaking, fairly good, but it's still not good enough to use that information to go out and finance a project,
Yeah,
or
right.
to feel comfortable enough for me to sign a purchase power agreement with Entergy or with the utility. So a big hurdle and a big cost for developing a wind project is you have to go out and get years of physical wind studies at a site, and for an offshore site, you got to do a couple things. Usually you put up a Met tower, so it's it's a 300-foot
I'm
pole.
real familiar, we built
with
one
an
off of
antenna.
Galveston.
And then you put a LiDAR, which is a laser, right next to it that shoots up 600 feet in the air, and it can dissect it can
One of the
dissect.
interesting data showed, on land wind projects, shear is the difference in wind from the top to the bottom.
That's right.
And that Galveston with 3 years of data showed we had no shear.
Oh, interesting.
And, at sometimes we had maybe a 1% negative shear.
So usually, in a lot of places, you want shear if it pays for itself. If it means you can build a taller tower
Yeah.
to capture that higher wind speed, great.
Yeah.
But if you're
You
capturing
got
high
wind at
wind
the
speed
bottom at
low,
5 and wind at the top 25.
then you don't need to
and
build a big tower.
The sensor
Yeah.
is in the middle.
You don't need a
The
big
pitch
tower.
for the blade is wrong through the whole. Yeah,
That's right.
that's a big issue for.
But so again, you're going to need a couple of years of wind data, and it's to my knowledge, no one has. I haven't seen, and maybe there are, but
I'm not aware of any.
but
But it's something. If the state got behind it,
yeah,
it's an opportunity to put our ports to work, and it answers a big question for Louisiana. Are we in the oil business or are we in the energy business?
yeah,
If we're in
exactly.
the energy business, we got a big future.
I agree.
The oil business, that world has changed.
It's I mean, of course,
The
there's
economics of it has changed.
there's a huge future for
Horizontal
energy.
drilling and all that, and there's enormous shale deposits across the country. We haven't even tapped that whole shale deposit up in northern Colorado and Wyoming and Utah. We haven't even
Yeah.
gotten into it yet,
Yeah, I mean, of course, there's a huge future for oil and gas. I mean, but generally speaking, what we've been talking about right now in the power markets, at this point, solar, wind, batteries are starting to become more competitive than any thermal resources that we previously had, and and from that perspective, Louisiana has a lot of land, a lot of great resources, for both hydrogen, for solar, for batteries, and we have a lot of industry that, hopefully will come or stay because
Sure.
they're buying power.
I got involved with a company that's invented hydropower. They're working on hydropower. And of course, you gotta have the right spot, but one of the ideal spots for us would be the White Lake outlet.
Oh yeah,
It's high velocity, it's a canal, it's straight, probably runs 9 months of the year.
that's
at
that's
3 or 4 miles an hour.
That's tidal. It's called tidal energy turbines.
Yeah,
So usually with hydro, obviously you usually do it at dams, and really what you're looking for is a big drop in
big
water
drop,
and big
400 or
drop in water.
500 feet, yeah.
Exactly. And so have been some companies, unfortunately.
See, we have a hydropower unit at Vidalia.
Okay,
and
yeah,
it's between the Mississippi and the Chafalaya.
okay.
And it's 66 megawatts, and it costs like $850 million, so, I mean, it was,
But, it's gonna last a while, and
yeah, I
and
guess,
and it's
it's
reliable
been there for a long
forever.
time. But it uses propellers, and this company out of Canada is using a rotating device that's horizontal. It couldn't be vertical, but it's a different concept
Well, it's
altogether.
essentially like a propeller, like kind of like a wind turbine underwater, and so you would
But
essentially
that's what's they're using it, if I dare you.
that's what they,
But
oh,
this
okay.
doesn't use that.
Oh, interesting,
Yeah,
okay.
it's a lot more efficient.
Well, I've seen some, so yeah, I'd be curious to look at that technology. There's a lot of applications for that, both in a lot of rivers and streams where it allows you for not having to dam that river or stream
Yeah.
and capture a lot of that energy, which, again.
And of course, there
historically-
again, it's limited in where you gotta have the stream,
Yeah, you have to have a stream with good velocity, good volume, and then also close to transmission.
Yeah.
And usually those projects as well, they're smaller turbines, and so you have to spread them out also quite far because the turbine in front will create a lot of wake.
Yeah.
And for the one behind, so you have to space them out. But I'm sure there's a lot of places, and I'm sure in Louisiana there probably are some interesting locations
Well,
to do that.
we have the mighty Mississippi.
Yeah, exactly.
Which is not so mighty anymore.
Well, yeah, in certain places for sure.
So we have possibility of thermal power in Louisiana. I mean, there was some thermal wells put together. One, I think, near Lake Arthur. And
Oh,
I don't know
really?
whether they actually produce, but I knew they were trying to tap into it.
Like geothermal?
Geothermal, yeah.
Interesting. Yeah, I mean, that's the best. Iceland, for instance, that's what they run
That's
their
what they
whole
run it
country.
on.
And more
There's
than
projects in Alaska use geothermal.
Yeah,
And they had one area, it only got to about 185 degrees, and they produced steam by putting a vacuum on it.
oh, yeah, exactly.
Yeah. It's
Yeah.
a small community, but it
That's all
was a
you
very
need.
successful project to use thermal. They didn't have enough to get it to boiling, but,
So what I'm optimistic for is that if we can integrate a combination of all of the available technologies and have them distributed, that'll create more reliability, more cost competitive
right,
energy,
yeah.
and getting away
And then
from the
proximity to need,
Yeah.
more resources like
Closer
the
to the
solar,
load.
solar facilities are all over the state.
you can be closer to where
Yeah.
the power's used.
Yeah.
You can
So you don't have big transmission loss.
you can use the transmission more efficiently.
Yeah.
And so, generally speaking, I think if people, just generally, regulators as well as consumers, we're open-minded to, all technologies and trying to find a mix that I think having a good mix of all of them. And I think there's a future for
And
nuclear
the
in
key
there
is
as well.
dependability, reliability, and as low cost as possible.
Exactly.
Yeah.
And that's it.
Yeah, and I'm Lafayette has peak power. We pay peak power demands for commercial.
Oh, yeah,
And the
peak
most
demand charges for
Peak demand
users.
charge, yeah. The most used in 15 minutes of a month is what you charge all month,
Yeah,
which more than doubles your price of power.
I'm sure.
Which, yeah, it really does. I mean, they have a charge that, like normally, like a big hospital, they actually getting 40% of what they're paying for.
As a peak demand
The
charge.
capacity, yeah, right.
So that's where a lot of
So they're paying 10 cents, but if you're only getting 40%, you multiply the cost 2.5 times, so your 10 cents goes to 25 cents.
So a lot of customers, what they'll do is they'll try to figure out how to shave those peaks.
Right.
And you can have an on-site generator
Yeah.
to shave those peaks.
You
And
can
a lot of times
save a
it's
fortune with it.
it's competitive.
Yeah,
So people will start doing that with batteries as well as they've been doing it with diesel and gas
Yeah.
generators forever.
yeah.
But
The Genbach engines, are super efficient,
yeah, there you go.
long lasting. They run 60, 70,000. They're real slow running. They run on, they're designed to run on landfill gas, but they run a lot better on landfill gas. Has a lot of silica, and
Oh,
it's
really?
very corrosive to an engine. But they run just as well on natural gas.
So, I mean, I'm curious to see, I'll definitely do some more research on LUS and, specifically in their integrated resource
We
plan.
got
you put
about 2
out.
minutes left.
But,
Thank you, Carlos, for
okay.
being here and sharing all your knowledge, and good luck with your projects. Okay.
Oh,
And
thank you.
I think sharing your knowledge with the people in this area is super important. That's why I asked you to be on the program, the importance of wind, and our area is getting a lot of the wind projects, and we should find our way to
Solar,
look
yeah.
into it.
Yeah, I think
Yeah.
so. I mean, I think being open-minded about the economics, about how competitive these technologies are, regardless
And
of.
I don't know if we violate the MISO contract if we buy wind projects on the side,
Wind or solar, or what are you-
solar, either
Uh,
one.
Oh,
We
if
don't
you
have
buy-
any wind available, but that may come in the future.
If you, what do you mean on this?
If, say, Lafayette contracted with the solar plant that's being built here in Lafayette
Yeah.
Parish,
Oh, yeah.
you know,
I don't think. Well, usually
we
when you're
just
buying
buy
from the
less power
wholesale,
from MISO.
you're buying from the wholesale. It's okay.
Yeah.
Unless you're. And usually, I'm sure LUS is working with different market makers and hedge providers. And I don't know the length of times where they buy stuff, but yes, generally speaking, I think
Yeah.
making sure that utilities across the board, both LUS as well as the state's utilities,
Sure.
evaluate all of the opportunities available to them to make it most reliable, most competitive is
Yeah.
important. And I think renewables plays a big role in that.
Thank you, Carlos, for being on the program. We appreciate it very much.
Thank you. Thank you.
Good
Harold.
luck with all your projects.
I appreciate
Yes,
it.
sir. One. Great.